Good morning, students. This is Murthy sir. Today we will discuss about an interesting topic, the structure of atom. First, we will go through the basics. Atom is the smallest particle of matter. Atoms combine to form molecules. Atoms are extremely small. To study the details of atomic structure, scientists they use an instrument called spectroscope. An atom contains a nucleus which bears positively charged protons and neutral charged neutrons. Electrons are negatively charged, which continuously revolve around the nucleus. Students, here you can see the atomic structure. In the nucleus, you can see protons and neutrons, and surrounding the nucleus in different orbits, the electrons continuously revolve around the nucleus. This happens due to electrostatic force. The positively charged protons will try to pull the electrons, and the negatively charged electrons will try to pull the positively charged protons. Because of this electrostatic force, the electrons continuously revolve around the nucleus. Electrons, protons, and neutrons, these are called subatomic particles. In an atom, the number of protons and electrons will be the same, and this denotes the atomic number, which we write with symbol Z. Electrons were discovered by J.J. Thomson. Electrons are negatively charged energetic particles, and these electrons are solely responsible for different chemical reactions. The atoms of different elements, to attain stability, to attain octet, some atoms they lose electrons and some atoms they gain electrons. Protons were discovered by Ernst Rutherford and Eugen Goldstein. These two scientists contributed for the discovery of protons. Protons are positively charged particles, subatomic particles, which are present in nucleus of atom. Neutrons were discovered by James Chadwick. These neutrons are present in the nucleus of atom, and they don't carry any charge. They are neutral charged. The number of neutrons may vary in the atoms of an element, which leads to the formation of isotopes. Some elements they have isotopes. In these isotopes, the number of neutrons will change. Light plays an important role in our lives. Visible light is actually electromagnetic waves. Just like a vibrating guitar string produces sound waves, vibrating electric charge produces electromagnetic waves. Now let us see the wave nature of light. When an electric charge vibrates, it creates changing electric and magnetic fields in perpendicular to the direction of propagation of wave. Let us see this in the form of a diagram, how the electric and magnetic fields form in perpendicular to the direction of propagation of wave. The sunlight that we see every day is actually electromagnetic radiations. In that, different types of electromagnetic radiations are there: UV rays, gamma rays, X-rays, ultraviolet. Students, here you can see the red colored region is electric field and blue colored one is magnetic field. Both are in perpendicular to the direction of propagation of electromagnetic wave. Like ocean waves, electromagnetic energy is characterized by wavelength and frequency. Wavelength is the distance between two crests or troughs. Frequency is the number of crests or troughs that pass by a given point per unit time. Students, here you can see the equation for wave nature of light. C is equal to nu lambda. Lambda is wavelength, nu is frequency. C is the speed of light, 3 into 10 to the power 8 meter per second. It was calculated by an American physicist, Albert Michelson. The range of wavelengths and frequencies covering red color to violet color is called the visible spectrum. Here you can see the diagram of the visible spectrum. Students, you might have observed rainbow during rainy season. The entire range of electromagnetic wavelengths and frequencies is known as the electromagnetic spectrum. In this electromagnetic spectrum, the visible spectrum is in the range of 400 to 700 nanometers. So, our human vision is in between 400 to 700 nanometers. Students, in this diagram, you can observe the wavelengths and frequencies of different electromagnetic radiations. German physicist Max Planck proposed that electromagnetic energy is emitted or absorbed in multiples of h nu. Example, h nu, 2h nu, 3h nu, nh nu, like that, but it is not in continuous manner. Here you can see the equation for the energy of photon, E is equal to h nu, where h is Planck's constant. A photon is the smallest discrete amount of electromagnetic energy. It is also called quantum. In plural, we will say quanta. Light is actually electromagnetic energy. The energy emitted by electrons is actually electromagnetic energy. Max Planck proposed quantum theory. He was the pioneer of quantum physics. He was awarded Nobel Prize for his contribution of quantum theory. Students, practically you know that some chemical substances, they exhibit a color of their own. For example, hydrated copper sulfate will be blue in color. Sodium vapors, sodium vapor lamps, they produce yellow colored light. Each element emits its own characteristic color. These colors correspond to certain wavelengths of light called the line spectra. Niels Bohr explained the line spectra of hydrogen atom, but he couldn't explain the line spectra of atoms with more than one electron. Hydrogen has one electron, but the atoms of different elements, they have more than one electron. Those line spectra he couldn't explain. So that is one drawback in Bohr's theory. But Niels Bohr's atomic model is an important step in the detailed study of structure of atom. So his atomic model, some limitations are there. Actually, he proposed circular orbits for the movement of electrons around the nucleus. It was later modified by Arnold Sommerfeld. He retained the first orbit as circular orbit, but remaining orbits he modified as elliptical orbits. So this Bohr's atomic model was modified by Arnold Sommerfeld. Niels Bohr proposed that electrons revolve in circular orbits in his atomic model. Arnold Sommerfeld modified Bohr's atomic model and proposed elliptical orbits while retaining the first one as circular orbit only. Students, even planets, when they revolve around sun, they move in elliptical orbits around the sun. So here Sommerfeld modified Bohr's atom by proposing elliptical orbits. You can see in this diagram here, the first orbit is spherical, circular. The remaining orbits, they are elliptical. Finally, the most accurate atomic model was proposed by Erwin Schrödinger. He proposed quantum mechanical model of atom, or it is also called electron cloud model. He proposed this atomic model based on the quantum theory proposed by German physicist Max Planck. So Schrödinger's atomic model is the most accurate one. He could clearly explain the position of electron, which is revolving around the nucleus in different orbits. So based on quantum theory, he proposed an accurate atomic model. This Erwin Schrödinger was awarded Nobel Prize for his valuable contribution to the structure of atom.